complex numbers, of course, why we have this section, we kind of already preluded to this a little bit. If you have the square root of a negative number, you have been putting down no real solution. Well, now we want to get into the set of complex numbers and actually talk about using those and simplifying it for our negatives. So we're going to take a look, of course, arithmetic operations on complex numbers, adding, subtracting, multiplying, all super easy. I'm going to show you too how you can do dividing. Dividing always takes a little more time because, really a fraction. Square roots of negative numbers, for instance, I'm pretty sure you know what the square root of -4, what you would write for that. And then we're going to do, like I said, good little review of some quadratics here today, but we're going to have some imaginary answers in those. All right, nothing really to fill in on your notes except at the very bottom of the screen here, this little blank, we'll get to that. But let's just take a look at what is a complex number. So of course, negative numbers do not have real square roots. To make it possible that all quadratic equations have answers, we are going to use complex numbers. So this, of course, is key, that a plus bi. Now, the order does matter when you write your complex number. You have to write the real part first. That's just the order, the definition, and then the imaginary. So that's just one thing to be conscientious of. So like obviously here, this is a great perfect order, 3 plus 4i. If you had it switched, 4i plus 3, you are technically not in the correct standard form of a complex number. Always real plus imaginary. Now, for our purposes, you will see some very common values of I, of imaginaries. And of course, I'm just on the side, I'm going to make a little list, is our square root of -1. So if I said, what's the square root of -4? 2i. Square root of -9? 3i. So on and so forth. We're going to see I squared today. So of course, I'm just kind of picturing if I squared both sides, that would cancel out the root. We're going to see I cubed today. So I cubed. We're going to see I to the 4th today. I could do this all day long. So I'm thinking I to the 4th, I squared times I squared, or -1 times -1. So one thing there, of course, math is all about patterns. There is a pattern here. Your even exponents, squared 4th, they rotate between -1 and 1. So I know I to the 6th, -1. I to the 8th, +1. I to the 10th, -1. All day long. Same on the odds. So I cubed -I. I to the 5th, +I. Now, those are your most common values of I. I always hesitate if I should show this or not, but I'm going to because I like you kids. If you're ever like, man, I just can't remember, what's I to the 5th, then I need it. Well, on your graphing calculator, see that little I button above the decimal point there? See it, see it, see it? So let's say you're like, I can't remember I to the 5th. So just hit your second decimal point, and then I'm going to raise it to the 5th. Oh, yeah, there it is. There it is. Okay, there it is. So no reason to get any of these I values wrong, because you can always check them on the calculator, just for the record. Now, bottom, the little blank we have to fill in, pure imaginary number. So you just have the imaginary part. That means there's no real part to it. So of course, if we don't have a real part, we're technically representing that with 0. So the one little thing you got to fill in on the blank. Okay, so we're going to get into the arithmetic operations of all of this stuff, which you can see is that chart, that grid on the bottom there. I don't get carried away. I don't be like, oh my gosh, there's so much memorized. No. I just think like terms. If you're going to add or subtract, obviously, you're going to put the real parts together, like terms, and then you're going to do the imaginary parts. That's all it is. Keep your like terms together. No mixing and matching. Don't combine a real with an imaginary. Multiplying, of course, is just, you know how to multiply. You have to do the full FOIL. That's all that is. We're going to FOIL it out and simplify. So just your common sense operations, but we're going to have imaginaries in them. So let's do it. Flip the page. Now, quiz tomorrow. So, I don't know, like A, B, and C would be some good problems to know how to do with some imaginary, some good basic imaginary problems. Quiz tomorrow, A, B, and C. Okay, so first I'm going to do the real parts together. 3 plus 4. Ooh. Then I'm going to do, of course, the imaginaries. 5i plus -2i. 5 plus -2, We're going to make sure I have it in the correct order, real plus imaginary, and we're done. Love this stuff. Ooh, subtraction. Wow, okay. Let's do the reals. 3 minus 4. We're crushing it. Okay, 5i minus negative 2i. What's 5i minus negative 2i? 7i. Love it. Love it. Okay, C. Super easy still, just a little more work because we're multiplying, so we're going to FOIL it out. 3 times 4 minus 6i, 20i, and negative 10i squared. Now we got to do a little simplifying here, a little simplifying. Now, of course, we can put our I terms together. We'll combine that in a second. And remember, your standard form of a complex number, a plus b I, just I, not I squared. So I do need to simplify that. We should hopefully know I squared is super common. I squared, of course, is really a negative 1. So I'm going to replace that with a negative 1. So I'm thinking about that. So that's really going to become a plus 10 there. So I'm going to now put the plus 10 and the 12 together. So 12 plus 10, I'm going to make it 22, and then 14i. So questions on those first 3? Quiz tomorrow. Okay, all right, let's do D. I always kind of giggle about D. So we need to simplify it, of course. We don't want to leave it I to the 23rd. Obviously, we like to just have, I, etc. in our answers. Couple ways you could do it. I'm going to do it the long book way because I feel like I should. So I'm thinking about my smaller powers of I. I like to use I to the 4th because I to the 4th is just 1. So I'm going to see, okay, can I use I to the 4th to rewrite this? Well, 4 goes into it 20 times. 5 times, that would make 20. So I'd need 3 more. So I to the 4th, 1. And then what's I cubed? Look on your list, or punch in your calculator. I cubed we can simplify to. So I can boil this whole thing down. 1 to the 5th, 1. Now, I kind of giggle because of course, if you pull up your calculator, if you type in raise to the there it is. There it is. Okay. All right. Enough talk on that. Any questions on that? So like I said, there are 3 questions from 1-6 on your quiz tomorrow. A, B, and C, or you're like, good stuff? No. Good stuff to know. Okay. Getting to division. Now, of course, division is always fractiony. It's always more work. It just is what it is. Now, if you remember, I is technically the square root of negative 1. We can never have a radical in the denominator of our fractions. So we're technically rationalizing the denominator. So notice here they've got in your denominator plus, they're going to use minus. We're going to use that opposite, the conjugate. It's a little fancy vocab word, just like when we had the square roots in there. We're rationalizing the denominator is technically what we're doing here. So let's do it. And of course, express it in the form a plus bi. I don't care about the top, I care about the bottom. You can't have this I in the denominator. It's technically a radical. So I'm going to use the conjugate 1 plus. So there's the setup. Now it's just gross because we got to do all the multiplying, FOILing, simplifying, etc. So I'm going to start distributing the top. 3 times 1, 6i, 5i, and 10i squared. Now, the nice thing on the denominator, purpose of the conjugate is the middle terms cancel. So I'm going to skip them. And we should come out with a very nice, pretty answer down there without an I in it. Okay, let's see what we got. Let's remember, I squared negative 1, 10 times negative 1, so I'm thinking that's really negative 10. So I'm going to put 3 and negative 10 together. 6i plus 5i together. And I'm going to simplify the bottom. I squared, of course, negative 1, so you really have a plus 4 there. So 1 plus 4. So did we achieve the goal of getting the I out of the bottom? Yeah, okay, but nitpicky. Okay, remember directions. A plus B I. Meaning, I'm just going to split this up. I want a distinct real part and an imaginary part. So I'm going to make this complicated and make it -7/5. That would be our real part. And then my imaginary part's 11/5. A plus B I. Okay, B. Now this time, of course, you just have a single term down there. You don't have a plus or minus in it. So you do have some choice here. Now I could still try to use the conjugate. -4i. I don't really care about the 4 so much. That doesn't offend me, so to speak. 16i, I mean 16 is not awful, but why deal with it if I don't have to? It's the I that's the problem. So I'm going to put another one on, because then I'll have 4i squared. I squared is -1. We'll have a nice whole number down there. But of course I got to do all the distributing. Okay, 7 times I and 3i, 4i squared. So again, I'm thinking about I squared is really -1 times 3, so that's going to be a -3. You could just put -3, I was dramatic there. I squared -1 times 4. Now, I don't like the order, it's kind of messy. Let's kind of clean it up. I want real plus imaginary. So my real part is this piece of it. So -3 over -4. I'm just going to put 3/4. My imaginary part, +7 over -4, I'm going to make it -7/4. Okay. Let's pause. Okay, all right, just point out. Pro tips for you, pro tips. All right, I don't think we really have to talk about these a whole lot. I think you're going to know a lot of this stuff here. So, of course, when you have your square root of a negative, we never want to leave a square root of a negative. That, of course, is our I. Okay, so obviously, I'm not going to leave the square root of -1. I'm going to put 1i. Well, I'm not going to write the 1. Let's get out of this. I love this stuff. This is too easy. I'm not going to leave it the negative under there. I'm going to use I for it. So I'm going to put square root of 16, 4, obviously, 4i. And this guy, I'm going to use I, of course, for the negative, but √3 is prime, so I really can't do anything with that. I'm just going to leave it. Now, I would take this answer, but of course I got to be technical. Usually, of course, you think about your standard form A plus B I. Usually the I is at the end. That is really the technical best perfect answer. But I get sometimes like it's hard like to make that I outside your root and it's nitpicky. So I'll take either form. So quiz tomorrow. So of course those first few we did, the adding, subtracting, multiplying, are good to know for tomorrow's quiz. And maybe something like this is good to know for tomorrow's quiz. So like I said, light on 1/6 tomorrow because of the quick turnaround, because of the 3-day weekend and all the good stuff. All right, so last we're going to do a little more simplifying here. So this is just, take a look at it. I didn't want to bore you and do the whole thing, but if you try to multiply that right away and make it the square root of 12, 2 square roots of 3, notice it's not the same thing, okay? Or sorry, square root of 6, not the same thing. You have to pull these i's out first, put a circle in there, so you get that I squared, which of course is -1. If you just multiply them together from the get-go, you're not going to get the negative. You're going to miss the sign. So the spiel here is always take the i's out first before you do any sort of adding, subtracting, multiplying, dividing, whatever. Meaning, I'm looking at this, I'm like, ooh, they should have wrote that I square roots of 3. So I'm going to do that first. Square root of 12, I square roots of 3. I did just put the I in the front just so it's not looking under the radical for you. Okay, square root -4. We should take the I out. Square root of 4, of course, 2, so I'm going to make it 2i. Now, we could FOIL it right there. I don't think that's going to be too bad. We're going to have to probably do a little simplifying on the square root of 12. You could, doesn't matter, simplify the square root of 12 right now and then FOIL. You could FOIL and simplify at the end. You'll get the same thing, it doesn't matter. Personally, I'm probably going to simplify this first because I think it'll be smaller numbers and maybe I won't have to deal with something giant. So I'm thinking about that as 4 times 3. What's square root of 4? 2. So 2 square roots of 3 I'm going to make it. And then I'm just going to FOIL. Move it up here so I'm not clear at the bottom. So 2 square roots of 3 times 3. 2 times 3, 6. 6 square roots of 3. Got it. 2 square roots of 3 times 2i. I'm going to do the 2 and 2 together, so I'm going to make it 4i square roots of 3. Seems messy, but again, really I like the I at the back, but just so it doesn't look under the root. Negative I square roots of 3 times 3. So I'm just going to put the 3 out there in the front with it, so minus 3i square roots of 3. And I like terms, we can put those together in a second. And then I square roots of 3 times 2. So I and I squared. I'm running out of room here. Minus, it's going to be a minus. I'm running out of room. So minus 2i squared. Okay, so let's put these together. That's going to be easy. 1i square root of 3. I squared negative 1 with a negative 2. I'm thinking about that as a plus 2. So 6 square roots of 3, 2 square roots of 3, 8 square roots of 3. And then I'm going to have 1. I'm not going to put the 1. I'm just going to put I square roots of 3. Got it. So again, you could reduce the square root of 12 first like I did. You could do it at the end. You would just have bigger numbers. That's the only deal breaker on that. So like I said, the key. I mean, I really didn't teach you anything new there. Make sure you pull the i's out first. Otherwise, you won't have an I squared and you'll miss a sign. That's the whole spiel on that. It's one of those days. I'm not even going to pay any attention to that. Okay, so good stuff. I like these last few problems because good review of quadratics, of course. Thinking about our quiz tomorrow. We did a lot of quadratic stuff. We're just going to get some imaginary answers today. That's the only thing that's different. All right, solve the following. Well, as always, we try to factor. I try to complete the square. I'm going to use quadratic formula. I don't even think I have to get that fancy on this one. If that was a minus 9, I just factor x plus 3, x minus 3. No such luck. So what I'm going to do, I'm just going to try to get x alone. I'm going to subtract 9 off. I'm just going to use my inverse operations. I'm going to cancel squaring out, of course, with a square root. And there's our imaginary square root of negative 9 plus or minus 3i. Got it. All right. As always, we're going to try factoring. Does anything multiply to 5 and add to 4? We can't make the signs work. Right. Okay, good. We get to review. How about complete the square, just because that's probably the newest method I've showed you. You're probably good at quadratic formula. Just give us a chance to review. So I'm going to move the 5 to the other side, because there is completing the square on tomorrow's quiz, of course. Now to complete the square, remember it's half a b, and we square it. And just, for your quiz and thinking about it, remember, completing the square lead coefficient has to be a 1. It is, so I'm not worried on this problem. If it was not, I would divide that off first thing before I did anything else. Okay, half of 4, 2 squared. All right, purpose of completing the square, left side factors. Multiply to 4, add to 4, 2 and 2. Negative 5 plus 4. I'm going to use my inverse operations to get x alone. I'm going to cancel squaring with the root. We're going to use plus or minus. What's the square root of negative 1? I. And last but not least, subtract 2 and we're done. So the only difference is you have some imaginary answers, but the process of completing the square is the exact same as the stuff that will be on your quiz tomorrow. And of course, thinking about our quiz tomorrow, if you had square root of 8 in your answer, we're going to make sure we always simplify our radicals as much as possible. 2 root 2. You have the square root of 12, you're going to simplify that. All right, done with that spiel. Do you think that factors? I'm going to guess not with the 37, and we're getting imaginaries. I'm just going to guess it. So the question now is, do you want to complete the square or use quadratic formula? I'd probably go quadratic formula, because if I get to complete the square, it could get kind of fractiony. Nobody's in the mood. Let's review quadratic formula. X equals the opposite of b plus 3. Okay, clearly I'm going to need my calculator for this. I'm just going to put 24 squared times c all over 2a, 2 times 4. Now notice too, I just put 24 squared. I didn't put the negative on there. That was on purpose. That was by design, because whenever you square anything, it's positive. All right, punch that in. You can see I had to type it in earlier. Look at my sheet here. What do you have under the square root? Negative 16. Okay. Which we're going to simplify our root first before we reduce anything, because, okay, good spiel, thinking about our quiz tomorrow. This is really a 1 in front. You would have to be able to reduce all 3 of these whole numbers, 24, 1, and 8. I know 24 and 8 reduce, but you have to do the 1 also, so I can't reduce anything yet. I'm going to do the root. Square root of negative 16 for I. And now I'm going to, of course, reduce all of these down. What goes into 24, 4, and 8? 4. So let's reduce them. Or really, I'm going to get super specific here. Since you have the imaginary, I need it A plus B I style. So I'm just going to quick divide this. My real part, 24 over 8. My imaginary part, 4i over 8. So I'm like 4 over 8. I'm going to make it a half. Because I need it, because of the imaginary, the A plus BI form. That was so fun. So very, very, very fun. Any questions on that one? Okay, so